This is a Quantitative Commons example video using sales data. In this example, we have received an Excel file with some historical data from our new American partner. We need to get that data into our system, and actually it's somewhat of a mess. Let's start by dropping the file into the Quantitative Commons data pane. We will get rid of the rows above the header and create new headers from the first row. Let's also lose some columns that has no equivalence in our system. Having done that, we can go on and start recording any action that we carry out into a repeatable workflow. Since we have activated the fuzzy recognition functionality, symbolized by the almost equal to symbol, Quantitative Commons will remember and recognize this data source even though we have removed rows and columns. Now let's do some simple formatting, starting with the order date column, which we want in European format. Phone numbers are in various formats. Let's use a tool to solve that as well. Tool categories are found in the drop-down menus, and tools from the selected category appear in the right-hand side list. Clicking a tool reveals relevant user controls. Most tools affect the row or column that is selected in the data pane. Each order may contain multiple products separated by a line break. We have to break these up into separate rows using the Split to Rows tool. The products and quantity column consists of three parts: a descriptive text, the product ID, and the purchase quantity. Because of that final slash, we cannot simply remove all non-numeric characters, rather we have to remove the specific descriptive string. With the remaining part, we can split it at the slash character and remove the slash. We can then rename the columns. Okay, so we only have the product IDs, and we need to reference a different data source to get data about these products. Let us make a snapshot of the current state of our sales data, and then drop a CSV file with our product data into the unfolded dataset view on the left. We can click the product's data item to see the contents. The product ID in the reference file seems to be hexadecimal. Let's make it decimal. Now the price of each product is in US dollars, and we need it in euros. Let us first create a column for the price in euros. Then we will convert the price to euros using the exchange rate of, in this case, a specific date. In reality, we would probably wait until after joining the data sources and select values from the order date column as input dates. But with tens of thousands of dates, that would be a bad fit for a demo. We can then join the two data sources on the product ID column and optionally remove the original data items. Let us move the product ID column and round the euro price off a bit. Our next problem is that in the summer of 2021, there was a 20% discount on furniture that is not reflected in our data. Let's make a column to store the actual price. Next, we will stack a few conditions on top of each other. If the order date is between the 1st of June and the last of August of 2021. And if the category is furniture. Then we will copy the price in euros and paste it in the actual price column. Only rows that satisfy both conditions will be affected by these operations. Finally, we release the conditions. Let's sort by actual price to find the new values. Also, let's use the Handle Missing Data tool to replace empty cells with zeros. We can now use an algebraic expression to cut the price by 20%. X denotes the selected column, which in this case is the same as the one we're calculating by. This is a very simple expression, but you are free to write it any way you want. Finally, let us set forth a numeric condition, that if the actual price is 0, we use the old price. There are of course many ways to accomplish this result, and the proposed one may not be the best. As a final problem, we would very much like to have some geo-coordinates to be able to show the location of our customers on a map. To do that, let's first concatenate the city and state columns, add comma and blank space to the city column. Then add the contents of the state column as a suffix to the city. We could try to geocode each row, but given that there are tens of thousands of rows, it will be much faster if we create a data table with only the unique cities. Let us make another snapshot of the current state of our data. We can name it cities. The fastest way to get the unique cities is to simply get the frequency of the city column and remove the count. Let's create some columns for the coordinates. Geocoding the cities requires a Google API key. This is going to take a few seconds, so let's fast forward a bit. Next, we can simply join our cities table with our sales data. Right. With that, we are ready to load the data into our database. For simplicity, in this example, we will be using an SQLite database, but many relational and NoSQL types of databases are available. After connecting to the database, we select the World Sales Table to view available fields. We can then drag and drop from the data pane to pair the columns with the database fields. You get the idea. Let's skip ahead. Finally, click Execute Operation to send the data to the database. And that's it. And here's the really cool part. While similar tools would have you set up a connection to a specific data source within a workflow, Quantitative Commons will recognize the file you select or drop, or a table or collection from a database you point to, and suggest or automatically run the appropriate workflow. You can even let it loose on a file folder with multiple subfolders and have any data that is recognized processed when you are back from lunch. Using fuzzy recognition, it doesn't require the data to exactly resemble the data used to record the workflow. You can even train Quantitative Commons to recognize data that it has never encountered before. You can of course run a workflow manually, step through it, and since the data is automatically recognized, you may even run it without even starting the application. Just right-click a file and have it processed. Workflows can be exported to files, which will also contain any recognition definitions. Whoever you share it with can simply drop it into the workflow library to use it. It can then be edited or continued upon. If you like, you can drop a workflow into another one to combine them. Let's say a colleague sent us some workflows to analyze our American sales data. We could use them like this. By the way, if you are missing a tool, maybe there is some functionality that is specific to whatever you are doing. You don't need to worry. The library where all of the business logic of transforming data lives is completely open source. You can add tools, build upon existing ones, and share solutions with anyone with similar needs. And that's pretty much it. Quantitative Commons comes with more than 150 tools out of the box and unlimited possibilities to create more of them in C# or Python. Now download it and try it for yourself. Get creative, get collaborative, roam the commons.